And welcome everyone to my presentation about the new approach for machine configuration on the adaptive platform. In this presentation, I will explain why this new approach is necessary and also what benefits we gain from the new approach. And then I will talk about the rollout. How can we roll out this new approach both to the standardization and also to the AUTOSAR public community. But before I can dive into the presentation, I need to clarify one piece of terminology that may not be obvious to everyone. And this is the relation between a model and a meta model. So to make it brief, a meta model is giving structure to a model. At least that is the part of being a meta model that is relevant for this presentation. So a meta model is a model that gives structure to a model. And to put this into a larger context, we also know that models are serialized into ARXML files, and ARXML files themselves have to be validated against the XML schema. So the relation between the meta model and the model is also reflected in the relation between the XML schema and an ARXML file. But this has consequences. So when we develop the AUTOSAR meta model in order to generate the XML schema out of it, we have to follow some rules and we have to follow some patterns in order to make this transition between the meta model and the schema possible. And please remember this aspect because it will be important later down the presentation. So let's now get into the actual issue. So why do we need a new solution? What is wrong with the current one? And to explain this, I would like to use this small diagram in which the modeling on M2 level is displayed on the left, on M1 level is displayed on the right, and the top row represents the classic platform, the bottom row represents the adaptive platform. As you can see on the classic platform, we have basically two major parts of the AUTOSAR model, which is design and target configuration. The design is placed on M2, target configuration is placed on M1. And this has the benefit that the typically highly volatile target configuration, so here we have frequent changes, doesn't have an impact on the M2 model. So it doesn't end up in the schema. But on the adaptive platform, the situation is such that both design and target configuration are placed on M2. And that means every change in the target configuration, and believe me, this happens quite frequently, ends up in the schema. So we end up with a highly volatile schema, and that is not the situation you want to be in. The next problem is that when we create this target configuration in collaboration with the working groups who care about the specific functional clusters, we also have to apply the modeling patterns and the rules. And it is in many cases very hard to explain these rules and modeling patterns to people who are not familiar with this situation, who don't understand the background of these. And therefore, this creates a lot of friction in the creation of our work. So let me give you two examples. The first example is the multiplicity, which is limited to two possible values, 0 to 1 and 0 to star on the M2 model. And the background, again, is the generation of the AUTOSAR XML schema. But people want to use all kinds of different multiplicities. They want to say, okay, this specific piece of configuration needs a multiplicity of 1 to 5. And this is not possible on M2, but it would be possible on M1. The next issue is there are no default values on the M2 level because default values are not necessary to generate the schema. But people want to use default values. It's just not possible. the M2 level provides some limited amount to create vendor-specific model elements. But if you are any familiar with how the target configuration on M1 called ECUC works, then you know that this is really no match. So on M1, the definition of vendor-specific model elements is much easier and works much better. So how is the plan going forward? So we have a problem here. The problem has been identified. We want to have a solution, and the solution, okay, is obvious. We just switch to a situation where the general modeling strategy on the adaptive platform reflects the already successful modeling strategy on the classic platform. Let me give you an example of how this looks like in a specific, albeit very simple case study. It has to be simple because time is limited, and I can't go into as many details I would like to. But here on the left side, you can see a specific model relation on the M2 level. You can see that all the rules, or the roles, sorry, are placed directly into this diagram. If you want to change anything here, this would directly end up in the schema. It's a very complex modeling that's certainly has some value. But if we switch over to the more simple M1 situation, we see that there are more blocks which we need to do the modeling, but each block is very simple, so they don't have the complexity of the M2 model. So as you can see, the relations between the blocks are just a container can have a container, or a container can aggregate elements. That's basically it. And each of those elements can have an arbitrary multiplicity. So here we have one example where the multiplicity is 1. Here is an example for 0 to 1. And here is an example for 0 to star. And here we see it is possible to define a default value, and this is also possible to define a range of values, an allowed range of values, which is not possible here. So in the end, although these two models basically represent the same functionality, this one is even more powerful because it addresses the needs of people working with target configuration models in the field. So to summarize, the benefits that we get from a new approach. I already mentioned the model structure is much simpler. We also have the ability to define default values as explained in the sketch from the previous slide. Function cluster specific terminology can much easier be applied because we are no longer limited to the existing model elements on the M2 level that are used for a specific purpose. That's called a pattern. That's we are typically using on the M2 level. Multiplicities, as already explained, are no longer a problem, so they can be chosen arbitrarily. And it's also possible to define vendor-specific extensions. This is not part of the example. The example was a little bit too simplistic to get all the aspects into this one example. And it is possible to respond to changing requirements without having to wait for a new schema. As a side catch, it is also we also get a much better separation between design and target configuration because design and target configuration happen on different meta levels. So all in all, for people who don't use modeling all the time, who are not doing modeling as part of the modeling working group, for example, they tend to be much happier with an M1 model because an M1 model gives them more freedom, is easier to explain, easier to apply. And I think this is something that we should take benefit from. So let's now switch to the impact of this new approach to the standardization. As I mentioned before, I already mentioned the term ECUC, which is used on the classic platform, which is basically the role model for our new approach. this is more or less taken over into APMC, but in a much simpler form. So ECUC needs to take care of some code generation aspects. So for example, to consider this symbolic name value approach. Also in ECUC, we have post-build variability. This is not possible on the adaptive platform anyway, so APMC doesn't have to support this. But of course, in order to use APMC, it is necessary to have the ability to define parameters on M1 level and also the ability to define values on M1 level. This has to be embedded into the meta model, because if it's not in the meta model, it cannot be in an ARXML file, but it needs to be in an ARXML file because you need to use it in a development project. And this part of the overall approach for APMC, this is handled in a TPS document, and I'll explain more details about this document later. So the parameter definition M2 model is basically defining the vocabulary for the parameter definition on M1 model. And the parameter definition on M1 model is what typically ends up in the chapter 10 of an SWS document for a specific functional cluster. So this part is more or less in the responsibility of the working groups who do the functional cluster design. But of course, the modeling will be or is typically supported by the modeling working group. This part of the diagram is not part of standardization at all, because the M1 parameter values is what people are using in the field to carry out their development projects. I already mentioned this new document. It's called TPS machine configuration. It is taken out of the existing part of the TPS manifest. So this document also defines the design on the adaptive platform and the target configuration on the adaptive platform. But the target configuration at least has now a new corresponding document which represents the APMC approach. And the plan is to finally, in the end, phase out the TPS manifest and take the design part also into a different document, which has to be defined at some point. At the moment, there is nothing concrete available for this. But there's also no need, because if you look at the timeline for how we plan to switch over from a complete M2-based target configuration approach to a complete M1 APMC target configuration approach, you can see that there will be several AUTOSAR releases in between. So we are not planning some kind of big bang in which we discontinue the existing model and the existing target configuration and wish everyone a nice day. Tool vendors need to create new tools which can deal with APMC models, and that takes some time. And also OEMs are currently running their development projects, and they don't want to switch to the new approach while the development project is ongoing. I think this is very much obvious. So they will have to plan a point in time when they can switch over to the new approach. And in the meantime, they can get familiar with the new approach and gain some confidence in what it can deliver. But in the end, after we reached a full coverage of APMC, we will reach a milestone in which the TPS manifest is no longer needed and can be discontinued. But as I mentioned here, I have no idea when this will happen. So it can be 26.11, 25.11 is certainly not realistic, or 27 or 28, I don't know. But at some point we will reach this milestone, and then the described switch can happen. So this is the very brief walkthrough through this new approach to target configuration on the adaptive platform. If you have any questions, I'll be available in the networking session for your questions. I would also like to remind the colleagues from the functional cluster working group to take this presentation as a reminder that work on APMC models can start right now. So if you like, we can just go to business and talk about the concrete modeling.